Well, today we're going to start talking about areas of polygons, and there's some different terms there. If you read that top part, explain to your neighbor what the apothem is. Like in your own words, don't just read it. Oh, too many of you are reading it right out of the book. Like, explain exactly what it is in your own words. What would you call it? All right. Hey, so the apothem, anyone want to give me their description? Maddie?
So it's like the distance from like the center of the polygon to like any side, like to any side of the polygon.
Good. And I'd add just one little piece to that. Distance from the center to any side intersecting at a right angle. Okay. That is the apothem. Okay? And I know that that's kind of what it says here, but it's really important to distinguish between apothem and what a radius is. The radius of the polygon is the radius of the circle. Okay? So when I'm looking at this and I'm saying, well, that's the apothem. Notice it doesn't go all the way out to the edge of the circle. This is the radius of the circle. Now most of you are like, well, of course that's the radius of the circle. Okay? Well, that's kind of a key term that you don't necessarily see here. All right? Okay, so taking a look at exploration 1, I want you to look down here. Okay, it says work with a partner, use dynamic geometric or geometry software. Okay, well, the dynamic geometry software that you would use is on your Chromebooks. So you actually have to go to Clever. Okay? We're going to give this a go. We're going to set a time limit on it. Okay? So you're going to use that to construct the polygon with these side links as shown, and then find the apothem. Okay? You need to go to Clever, and then here, I'll help you try to get there on my computer here. Okay, so if you go into Clever, and once you're into Clever, go to your textbook, your online textbook. Let's see. Hopefully yours is going a little faster than mine. Okay, so the student dynamic ebook. Okay, I need to get in the correct class though. I'm in algebra right now. Okay, so once you're in the student dynamic ebook, you go to 11.3. How many are there? How many are waiting for it to load? Sorry. I'd brag, except for my computer's going to probably log down. Student dynamic ebook. It's pretty dynamic if you can get there. If you can't get there, it's not as dynamic. It's just a student ebook hanging out there. Since that did not work and technology is fun, we will not be using the exploration. So, let's turn the page to page 326. I'm sorry, I tried to get a cool experience there, but it was an experience in waiting. So, I taught you how to be patient with your computer. If you broke your screen because you got really irritated, then I didn't teach you anything.
I feel like all these parts in this chapter are really short.
Yeah. Okay, well, look at page 326 anyway. Let's talk about some of this. We used the picture on the top of page 324 to reference, the center, the apothem, and the radius. Okay, those are all things that are referenced right here. Please remember that the central angle of a regular polygon is any angle that moves from the center of the circle and and breaks 2 radii here. So the central angles we're discussing in this one would be that, and that. There are a total of 5 of them. Since it's a regular polygon, what do we know about the central angles? They're all equal. And so what would each of these central angles measure? No, the whole thing would be 360. 360 divided by 5, which is 72. Each one is 72 degrees. Yes. So each central angle there is 72 degrees, which, by the way, makes this angle right here, half of one of those, be 36 degrees. Okay, now we're going to utilize those ideas when we find areas of regular polygons. So I'm going to skip the bottom of this right here for a minute on page 326. And I'm going to go to the top of page 327. We're going to talk about the formula for area of a regular polygon. Area of a regular n-gon, which means a polygon with n sides. So a 4-sided would be a quadrilateral. 8-sided would be a regular octagon. Okay, we're just saying n-gon. With the side length of s, okay, is 1/2 the product of the apothem and the perimeter. All right. So for those of you that look at this figure, if I didn't give you a formula, how would you go about if I knew that this was a regular polygon, how would you go about finding the area of the whole polygon? Ignore the formula for a minute. What would you do? Don't get mesmerized by my bling up there. Here. Okay, Ian? Okay, so find the area of one triangle. And then multiply it by the number of triangles. How many agree with that? Okay, how do you find the area of a triangle? Okay, so everyone just follow along with me here. Base times height divided by 2 is the area of one triangle. Times the number of triangles. Well, how many triangles are in this one? 6. How many sides are there out here? 6. So is it safe to say the number of triangles is going to be the same as S? Yeah, we could say that. So the number of triangles we could call S. It's the same. If there are 6 sides, there's 6 triangles. If there are 7 sides, there are 7 triangles. Everyone with me there? Did I lose anyone? Okay. Yeah, I did? No? Yes?
Why are you using S? Because S is like the length of the number.
Right, but the number of triangles is always going to be the same as this.
So like if the side
Oh, I see what you're saying. You're saying, so that's... Okay, so I understand what you're saying. So in this case, let's use T for triangles, number of triangles. Does that work? Okay, so if there's number of triangles, we're just going to call T. Okay, so we're going to do base times height divided by 2. All right, what's the base? Let's take this triangle. What's the base of this triangle? 3. Base is S. All right, I don't know where we got 3. Okay? What's the height? Height is A. So B became S. H became A. And then divided by 2. Okay? What's T represent? Number of triangles. Another way to think of it is the number of sides, right? Everyone agree there? If I have 1, 2, 3, 4, 5, 6, I could take the number of sides. In this case, it would be 6, or we're calling it T. Maybe we should have called it N for number of sides. Okay? We're going to take the number of sides, or number of triangles there, and multiply it by that. All right. Everyone good there? Let's go ahead and try to simplify this formula for me. So you're like, what do you mean? They're fractions, right? This is a fraction. Where would that t go? Multiply fractions, you get t times s times a, all divided by 2. What's another way of writing that? Rather than dividing by 2, what do you multiply by? Yeah, you multiply by 1/2. 1/2 times t times s times a. A stands for Apothem. Apothem. Okay? Apothem. T stands for number of triangles. S stands for what? Side length. So if I take the number of triangles and multiply it by the side length, so if I have 6 triangles times S, what do we call that? What's that? Yeah, we call that the perimeter. If I take the side length and multiply it by the number of triangles, that's always going to be my perimeter. So this piece right here could be replaced with perimeter. So 1/2 of the perimeter times the apothem equals our total area. That is what this formula right here is giving you. 1/2 AP. Okay? Now note that they also said, or you could say 1/2 A times N times S, which we should have probably used N instead of T. Okay, we said T times S, but the same thing. Remember, N times S is your perimeter. This only works with a regular polygon. Okay? So what I want you to do, let's go ahead and turn the page. I want you to look at number 3. It says, find the measure of a central angle of a regular polygon with 8 sides. Okay? And then read through number 4. Okay, go ahead and close your Chromebooks, guys. Number 4, the central angles of a regular polygon is 40. How many sides? Have you been asked to find the area yet? No. This formula right here, though, says area. Okay, it doesn't have anything, like, it's not in terms of central angle. Okay? It's not in terms of number of sides. We've got to be able to manipulate that formula a bit. And then number 5 goes, a regular pentagon has a radius of 4, a side length of 3. Find the apothem and then find the area. So number 5 is where you actually start to find the area. Okay? The first thing we're going to do, though, is try to do number 3, where we're going to practice this. Find the measure of the central angle of a regular polygon with 8 sides. There's a reason they're having you do that. You're going to see it as you get down here. Okay? All right. I want you guys to try number 3 with your groupies. Okay, some of you picked it up really fast. I heard you talking about it like right after we said. Some of you may still be struggling. Anyone want to explain how you did it? Nathan?
Well, you just kind of apply 360 divided by 8, knowing that the measure of the polygon is going to be consistent total and it's 8 sides.
Yeah, so if you take 360 divided by 8, you think back to our previous, when it had 6 sides, there were 6 triangles, which meant that it's broken into 6 equal parts. Therefore, if there are 8 sides, there's going to be 8 triangles. So it's going to be broken into 8 different parts, which gives us 360 divided by 8, or, what is that? 45 degrees. So finding the measure of a central angle, 45 degrees. All right, everyone try number 4. Taking the next step. Okay, here where we did number of degrees divided by number of sides. Number of sides is equal to central angle. You can kind of set up a formula where you're saying, well, if I know the number of, or the central angle, I could take that and I can divide that by, or 360 divided by the central angle, and that will tell me the number of sides. That would be 9 sides. So if there's 360 degree and you're dividing them into 40-degree chunks, there's going to be 9 of them. All right. So now utilizing that, number 5, regular pentagon. Pentagon has how many sides? 5. I suggest sketching a picture of it. Does not have to be an amazing picture. For those of you that aren't familiar with the Pentagon, it's a house, and when I'm sketching a picture, I'm doing dots. So here are my dots. That is why when you were little, we give you connect the dot pictures. It's like a mathematical conspiracy against little kids. So that now when you're older, if you put the dots, you know how to connect them. You can draw shapes. Now some of us are better than others. You're like all pro dot connectors. Some of you are still in your amateur status, so you could compete at the Olympics. Okay? Now, that'll work right there. Doesn't have to be amazing, but what we do know is that it's regular, meaning all sides are equal. So if you didn't remember that regular means all sides are equal, make sure you put that. All angles are also equal. All right. Okay, it has a radius of 4. Where does my radius go to from the center? Yeah, it goes to one of the vertices there. Has a side length of 3. Find the apothem. Ooh, that's this. It's awesome, apothem. Okay. Notice it's a right triangle. That's pretty cool. Go ahead and work with your groupies. Find the apothem there. What's this length right here? Yeah, it's half of it. Yeah, 1.5. This is our A. We do our A squared, B squared, C squared, so we get 1.5 squared plus A squared equals 4 squared, or 16 equals A squared plus 2.25. A squared is equal to 13.75. So A is approximately 3.7. Now we're going to use an approximation there. If you're using an exact value, it would be exactly the square root of 13.75, which is poor form to leave a decimal and a radical. Yeah. You could, you could. Probably easier using the Pythagorean theorem, maybe a little faster. So find the area of the Pentagon now. Let's go ahead and use the rounded value on that. I'm not a big fan of doing that, but we're going to go ahead and use that right there. Okay. Pretty exciting. We already got it. So we need to know our apothem, and we need to know the perimeter. What's the perimeter? Yeah, 3 times 5, or 15. So we do all the math there, 27.8. Okay, so we round up to, okay, good. That's an approximation. Pretty good. There are 5 sides. Yeah. Yeah. So the length of one side times the number of sides. Okay. Questions? Just applying the formula. Okay, I want you to go to back to problems 1 and 2. You're not allowed to look at any other pages. Just this problem. So don't look at anything else. I want you to find the area of this shape. And then find the area of this shape. We'll talk about number 1 here in a minute. Yeah, hey, the 10 inches goes with this side.